I still need a jingle for this. Okay, let's get going. I think my cat's being chased. Hello, and welcome to Practicalli. Thank you very much for joining me. My name is John Stevenson, and today we're going to continue on with some more very simple kind of introduction to data science with Clojure. So last week we looked at just like a baby steps walkthrough from Dragon to mainly looking at how you can use Clojure to get information and transform it into the shape you want to. And then we had a very, very brief look at Oz, an example project to do some visualization around data science. So we're going to look at Oz in a bit more detail this time. We're going to build a relatively simple dashboard just to show you how all the mechanics work and give you some examples of the kind of visualizations you can create. There's a lot more that you can create than we're actually going to cover, but it should give you a good starting point. Ooh, here's my lovely website. So the website practicalli.github.io or practical.li has all the videos I've created, all the study groups, and some other videos on things like Spacemacs and installing the Clojure CLI tool, which you'll need if you want to follow on exactly with this project. And it's also the books I'm working on as well. I've done a lot of updates to Spacemacs, and I'll be doing some more updates to the other books over the course of this pandemic. If you want to reach out and touch me, then the Clojure and Slack community is a good place. There's a Practicalli channel if you want to discuss things specifically about the things that we're doing here. And you can also send me a direct message. There's also lots of other channels on this Clojure and Slack that are there to help you, and they're all very friendly. And you can also subscribe to my YouTube videos as well. If you want to financially support me as well, then there's either PayPal me or GitHub sponsoring. Any kind of those things does help me keep going, and I don't get any other financial compensation for doing this. It's not part of my job or anything, so any kind of motivation is much appreciated, and thanks to everybody who's already motivated me in that way. Okay, what are we going to do today? Well, I was looking around. I mean, we kind of based on the COVID-19 pandemic because it's excuse me. It's hard to not know about this worldwide pandemic. It is affecting a lot of people, unfortunately, but it's a useful kind of topic to look at some data science in. There are some data coming out. Most of it is fairly recent data as well, so it's quite relevant to kind of look at. And the information I found for the UK, there's if you go into the gov.uk website, there's a lot of really useful information on here about the cases, but also about what to do and how to like get lots of really useful guidance and how to take care of yourself and social distancing and so on. So it's great to see that is taking effect in the UK now, and so it should slow the spread of this virus in short time. And this is all from Public Health England, and if you do want to see the details, they do have a tracker, a desktop and a mobile version of a tracker. So you can track the number of cases, so we're going to have a look at that. It does mention unfortunately there are some tragic deaths due to this pandemic, and but so hopefully if you're staying safe, then you and your family will be okay. But it does give and they keep changing this as well, so it gives you various views on what is actually happening in there, and you can see that there's quite a quite a high infection rate, but relatively speaking, it's only kind of seriously affecting a small percentage of the people who are actually getting infected. So the more that we can do to flatten this cases curve, then again that would reduce even further the more serious situations as well. And this breaks it down into, I think this is a pretty useful dashboard in general, because it gives you kind of like the highlight data. So like what's the most important kind of facts about the particular subject, and so how many total cases, and where are they spread throughout the UK, and also then it shows like a geographical region as well, so you can kind of zoom into this and see regions which are more affected. Again, this is going to be based on where the tests are actually taken rather than where people actually are, so you do have to kind of take this with a pinch of salt. So again, it's just showing you the kind of numbers of people that have been recorded in a certain area. So there is some context missing about how many tests are actually taking place in this. So we've got how many cases have been reported, but we don't actually know how many cases how many tests have actually been done. Obviously, there's at least 17,000 tests that have been done, but we don't know how many more tests on top of that. Is that 1%, or is that 10%, or is that 50%? So it's still not 100% clear on the data. So again, take this with just as a very loose guide to what we've found out so far. And obviously that you can kind of see things like there's more concentration where there's more concentration of people. So again, that does kind of reinforce this idea of kind of keeping distance will help minimize the spread of that virus as well. So you can make some very general assumptions in that, but I'm not going to actually claim, even though this is from the government, they still have caveats in that not all their data is up to date, and some of the numbers are not as current as others. So again, take this with a pinch of salt, as it were. And they do have all the data available, so you can actually get that. So there's a daily indicators, which is the headlines, and then there's confirmed cases and so on. So I'm kind of going through some of this, and we use some of this data in there, but I'm also going to create some mock data as well, just to for brevity's sake. So we're going to try and build something like this. We're not going to build all of it. I'm going to build kind of a bit of this, a bit of these headlines, and putting some graphs. I haven't quite gone through all the information to get out all of this. I think this is from the like the UTLA data, so you need to kind of, that should be fairly interesting. And then also like the presentation of things. So what are we going to use? There we go. It's pinned there. There we go. Is that it? No, that's not it. Oh, there we go. That's something else. Yeah. So we've got some data we can use, and an example kind of use case. Obviously I'm not trying to replace this. I'm just trying to explore how we can build something like this with Clojure. And the library that we used, I've got too many tabs up now. I didn't tidy this up, unfortunately. So I'm just going to open a new tab. So Clojure Oz. So Metasaurus has created this excellent library called Oz, which is the Great and Powerful Scientific Document and Data Visualization library. So this is, allows you to build, and we'll do like something similar here. So it allows you to build charts and bar charts and other wonderful and weird kind of visualizations as well. So we'll start to build something like this and use some of the examples here and show you how to do that. We're kind of mostly following bits. I've taken bits from the this little REPL usage thing. So the nice thing is you can have like fast feedback as you're building your dashboard. You can have your editor and your web page side by side, and you can see the dashboard and the views you're creating as you go along. So we'll show that as well. So if I go back to Practicalli, I think hopefully this blog, yeah, there we go. I just published a blog post just literally 10 minutes ago. So if you go to Practicalli blog, I'll put this in the chat. So this is what we're going to walk through today. Oops, there we go. And so, yeah, I think I've covered all that. Oh, data science logo. So we'll try and build some of this. And this part of the, I'm not going to cover the the geographical map at the moment. It does require, you can download and find these maps. So I'll need to find where I can get a source for this. This is just expressed in terms of JSON. So if you can find the right map, then you can kind of just download these things and then just use them as a template for your visualization. Excuse me. I do have a bit of a cough. Hopefully it's not anything serious. Oh, and there are some other really, really nice dashboards I've seen. So there's this one here. So this website against COVID-19. I put a lot of effort into, well, first of all, finding the data, and then also helping to understand how to present it as well. And so this is a really interesting kind of dashboard. So there's a lot of things I'll look into kind of borrow from this as well. Oh, they've even got some United Kingdom sources of where they've come from as well. So distribution charts as well. That's really nice. So you should be able to do all this things with Vega. It's just I haven't actually got around to figuring out what all the charts are yet. But yeah, there's some really nice visualizations. There's a good kind of usage of color. I think there is a kind of undefined approach to not use too much red. It does send or using it like an off red color. If you use a bright red color, it's usually frowned upon. I think it's quite distracting apparently. Okay, so there's more examples there you can have a look at as well for inspiration. So the government does provide, the UK government does provide these sort of daily indicators and so on. So I've basically gone onto this page and just downloaded it. This is an Excel spreadsheet. So rather than deal with Excel spreadsheets, the actual data itself is just a CSV file. They've just put it in an Excel file, which for an Excel a Microsoft format. So I'm not quite sure why, but why they just didn't distribute it as a CSV file. But I just opened LibreOffice and saved it as a CSV file. So we'll use that later on as well. So we're going to start off creating a Clojure project. There is also, we'd looked at a different project last time. That was a Leiningen based project. So you can also use Clojure CLI tools. That's what I'm used to using. So I just did this Clojure CLI tools. So I just created a new project, which is an app, and it's the domain is Practicalli, and COVID-19 dashboard is the main namespace. I'll put a link here on how to install CLJ new and the CLI tools if you haven't already done so. I've got videos on that as well. Okay, so we've got there we go. So we've got this project. Let's show you the structure. So this is what the Clojure command creates. So we've got this COVID-19 dashboard. The docs don't really have anything in resources. This is where I've put, I've created a data folder in here, and I've put the XLSX data files that we downloaded. So these are the two I downloaded from, well actually I downloaded these three from the government websites. One of them is a CSV, the other two are Microsoft Excel. And then I've just opened the daily indicators one in Excel and just in LibreOffice, and just saved it as a CSV file. If we open that, you can just see it's just a simple CSV file. And then we've got the source directory. So I've got my normal source, which doesn't have anything in much just yet. And then obviously the test directory as well, which doesn't have any tests in as yet. I'm not quite sure what kind of things I would want to test. I guess we're testing any kind of data conversion that we're doing, any data transformation we're doing, and I wonder if, I'd have to think about what kind of tests I want to do around the visualizations. I guess again, we can see that the data visualization is just basically a data structure that is taken and processed. So we can test to show that we're getting the right data structure. Actually, it is just a map, so actually tests using Clojure spec might actually be more useful there. And finally, I've done most of the work in the design journal. So this is what we're going to work through here to show you what I've done so far. This is, if we go to, I'll put a link in the blog as well, but if you go to GitHub and Practicalli, then I think one of the latest resources is this COVID-19 dashboard. So I think this has got all the, did I push it? I don't know. Yes, I did. Oh no, I didn't. I didn't push it. I'll push that now, so we've got that. Oh yes, I didn't push, did I? Whoops, sorry. There we go. I'm just pushing all the changes I committed last night. So you should have those now on the website, on the GitHub. Oop, refresh that. Oop. Oh, I'm pressing the wrong button. Two screens. Yes. Oh, that's. Yeah. So we got the design journal now with all the code in here as well, and I'm showing the shape of data that we're getting as well. Okay. Oh, there's a few more changes that I'll push there as well. Come back to those. Okay. So we've added. Let's see. Let's look at the deps. So deps.edn is our configuration project, configuration for the project. So we started off with Clojure, latest version of Clojure that's stable. And I've added Metasaurus Oz, which is the Oz library. And that's all you kind of need to do for the visualizations. If you've already got the data, then you don't need to add anything else. But I've also added a couple extra libraries just to help me work with ingesting some of the data. So this is going to, so if we're working with CSV files, then this data CSV file is just a simple way of pulling in CSV data and putting it into a very simple Clojure data structure. This is just a vector. And Semantic CSV actually pulls that into a more useful data structure with kind of metadata in the terms that it's generating a map, and the keys define like meaning for the values that are in there as well. So we can basically pull in the headings and associate the headings as keys and the values as the associated with each particular key as well. So we'll see that as we go along. Let's go back. So the first thing you can do is start a server, And so this, if you do this straight away, then it's going to fire up a web page, and you're now ready to actually do kind of like live coding, because whenever you push a view to the server, then it's going to display it straight away. So I think, am I running this already? Oh no, I restarted the computer, so I'll start a REPL. So I'm just going to start a Clojure REPL, and this is using the deps.edn file to start. You can do all this in Leiningen as well. There's no difference to the code except you've got a project.clj file rather than the deps.edn file. So we've started that. We're going to require Oz. We've just got this as part of the namespace definition, and then we can start Oz server. And so now the little red things popped up to show me that my web page is my browser's opened a new tab. So this is open a new tab, and it's basically got a page that's open, and this is a page that's got a WebSocket that's listening for things to draw. So if we use the Oz view function, then that will push a view up here, and then the page will update. So if you have this website page open next to your editor, then you can see what's actually going on as and when we do that. So I'll move those together as a bit closer to the time. But first, some data. So I want to generate some data. So there is data from the government. It's not quite in the shape I want it to. So rather than kind of spend time on that, I wanted to see what kind of things I wanted to visualize and find out what Oz could actually do. So just created this very simple function. Again, this is basically what's in the Oz README. So it's basically generating, given a set of locations, so it will generate, for those locations, it will create a range of data sets, and each day will have, so we'll do it for like 20 days, and each day will have so each data set will have the day value, so that'll be 0 to 20, that's generated by range, and the location will be the location that we pass in as an argument, and then we're going to just generate the mock data. So this is just taking the value of the day, so it'll be 0 to 20 each time. So it'll be 0, then 1, then 2, and then 3, then 4. We're going to count how many there is. So it's going to multiply the day by like 20 each time. And then that value is put to the power of 0.8. So we actually reduce it, so we can actually get a kind of slightly smaller number. And then we add a random int from the count location, so a random int between 1 and 20, I think, and this generates basically a mostly gradually increasing set of values. So when we call this mock data set function, so we call it with England, Scotland, Wales, and Northern Ireland, then we get it's like day 1, and it's got 1 case, and then we start increasing up here. So it kind of gives us useful kind of information in here to work with, and so basically it's creating a sequence of maps, and each map is pretty much self-contained, so it's fairly easy for us to represent that as it was very easy for us to iterate over each of these maps and use the data that's inside them. We can we can use the keys to look up the specific data that we want in each of those maps. Let's just fold that up out the way. questions? No questions so far. So we're just creating some mock data. So again, I'm not using the government data just yet. We'll start feeding that back in towards the end. And then we're creating, so we've got our data set. Now we want to be able to have that data set so we can actually display it in any of these graphs that we're going to display. So the bit is a bit of a transformation. We're not actually really changing the data set that we've created or that we've got, but we are adding specific kind of metadata around that data set. So I've got something here called def line plot. So this is just a var I'm using to a name I'm using to basically hold the data that I want to view, and then it's a simple case of just doing OsView with that data structure. So again, we're just going to build this data structure, this map, and then view it. We're asking Oz to view it for us, or to create the view for us. And this map has 3 main parts. So it's mark, and that is, I'm not sure why it's using the name mark, but that is basically the type of graph that we're actually going to create. So we've got a line graph, we've got bar graph, and there's many others to investigate as well. And then there's the data. So this is basically our data source. So we just got our data as a map that has a keyword in called values, and that values is a sequence of maps that our mock data set is going to generate, or when we put our government data in, this will be our government data that we put in here. But again, it's essentially is just this sequence of maps, so this list of maps. So we've got the type of graph we want, the data we want to put in it, and the encoding is how do we put that data into the graph. So we've got X and Y coordinates on the graph and color. And so this, for a line graph, we've got, so the X value is day. So there's going to be days we go across. And for each day, there's the number of cases in that day. And we're just using location as the color, so that each location has its own color, essentially. So England, Scotland, Wales, Northern Ireland have their own colors. And I think these are just chosen at random, but you can specify particular colors as well. So if I evaluate that, oh, I didn't evaluate mock data set. There we go. Oops. It helps if you evaluate things in order. There we go. So is that working? That's working. Okay, cool. Yeah, that's working. So this should work now. There we go. Hello. Oh yeah, we're working. Cool. So we've got our data. We've got a line plot that's encasing our data. So that was working. And so now we can just do a view. So we do that, and we pop back to our website. We've got a view. Oh, no, we'll do that. So we can see if we zoom in. Wow. So I'm just zooming in on the page. Oh, 250%. So we've got our days. So these are our 0 to 20 days that we created. We've got our cases. So this is the mock data that we're actually generating. And then we've got our key, which is based on the location. So each of these are the locations that we've actually passed in to the data when we generated it. And we've got data for England, Scotland, Northern Wales, and Ireland. And obviously this is just mock data, so there's no meaning we can get from this because we've just randomly generated it. And if we make that smaller, what if we go? We move that to 3. Where's my browser gone? Yes. Oops. There we go. Sorry, I'm can't drive my own desktop at the moment. There we go. That's what I was trying to do. Let's switch those around a bit. So normally when I'm developing, then if I reevaluate the def line plots and then call it again, I should get different values. So this is a fairly easy way for me to generate that. And if I change this from a def to a defen, then I could just call line plots with the right arguments, and it would just generate a new data set each time. So it depends what you're trying to achieve, but you can see that I can try out, and because it's mock data, then I could put in generators that kind of show me like different ranges, so I can kind of test out the visual nature of the graph for the kind of wide data set that I want to actually display. So this is a good way to test out whether you're using the right visualizations for us as well. So that's a nice graph chart. It doesn't do anything particularly interesting. There's no annotations on top of this yet. I'm assuming there's some kind of encoding you can add to that to put annotations on, but that's not something I've delved into just yet. So we've got one graph, and we want to add, want to create another one. So we're not changing the data set. We're going to use the same data. There we go. Oh, that's interesting. Yeah, I can do that. Yeah, there we go. So we've got another def stack bar. This is going to create a bar chart using the same data. So we're defining what type of visualization we want. So we want a bar chart, and we're going to stack the values on top of each other. So each day is going to have the values for each of the locations. So we've got our data. Our data is exactly the same. Obviously, it's going to be slightly different because it regenerates each time. And then the encoding is different because we're kind of stacking the data on top of each other. So the x value, so the value along the bottom. I guess this is the time-related data. So that's days. So that's going to be 0 to 20 days. And then we're going to do the field, which is cases, and this is obviously going to do the confirmed cases, and we're going to aggregate each day by location. So we're going to put England, Scotland, Wales, and Northern Ireland all in the same bar on the same day. And yeah, the color is just based on the location again as well. One thing I didn't point out, I think, and might be a cause for confusion, is, well, how do we know what the fields are called? Well, they're in the data already. So if we have a look at, just expand this for a little bit. So here we've got day, location, and cases as the keywords, as the keys, basically. Sorry, the keys. Well, they are keywords, but they're the keys in the map. And so we're actually using those keys as the fields. So we're using field. The field will go off and look up the day value for each of these data sets in here, and same for cases and same for location. So we don't need to kind of do anything too complicated there. We're just basically matching the names of the fields to the keys in the data set that we're generating. So yeah, so if we evaluate that, and then let's just do bring back our web page and evaluate this, and we get a new chart. Yay! So here we've got a bar chart, and we can see that each day has kind of 4 values. We can see it at the end. So we've got Wales, Scotland, Northern Ireland, and England, and we can kind of see relatively they're all stacked upon each other. That's why it's a stacked bar chart, and we can see that how they, a very quick glance at how they compare with each other as well. Again, this is mock data, so it's not real data, but it's when we put in real data in here, we can kind of compare different regions in a nice visual way as well. And I think one of the tricks to doing data science is to find the right kind of visualization to express the opinion that you have about the data as well. Okay. No questions so far. Let's do that again. Let's put the code back. And so how do we tie this all together? So we've got a couple of visualizations. We've got these views that we're pushing. And so they're individual views. So we want to be able to put those together into a more cohesive dashboard. And that's actually the really simple part, because it's just kind of pseudo HTML, but in this case written in Clojure. So we use the Clojure hiccup syntax. So there is a library called Hiccup, which has been used with a lot of websites to generate content. It's much more easier to work with than the typical HTML tags, which have an opening and closing tag. So if you wanted a div in HTML, then we'd have to do div close tab, and then we'd have to do a closing tag. And yes, I know. But in Clojure, all we're doing is just creating a vector, and we're just using a keyword for the tag, and that's it. So it's simpler because we don't have to worry about forgetting the closing tag. And it's also, we can do structural editing on this as well, so it's very easy to manipulate and move things around. The tags in HTML are a little bit more fiddly. It's not as easy to do that kind of editing with those. And the nice thing is that these are just Clojure data structures, so we can very easily work with them as well. So I'm just defining a dashboard, which again is going to be another view, a view that contains other things that we want to view. And this is just got a div to just bring everything together. So usually have to just send in a single structure. So just wrap everything in a top level div, a top level divider. That's the easiest approach. If you're generating like SVG graphics, this might be SVG, or some container that you want to have here as well, although containers are usually a CSS style that you'll put onto a div. And so inside this, inside our page, so this is representing our kind of like our whole page, our whole dashboard that we want to present. And the nice thing is that as it's all in a div, then I can actually include this in an Uber dashboard. So I can create a dashboard of dashboards if I wanted to, just by creating a div with like dashboard and dashboard A, dashboard B, dashboard C. So it's very easy to keep on expanding this because these are just Clojure data structures. Oops. So I've got a heading in here. I've got a paragraph in here as well. So we just put the tag name and whatever we want to put in, what would normally go inside the tag. In this case, it's putting us a string. We don't use plain text. We use text in strings all the time because the text, obviously in Clojure, is going to be interpreted as a symbol, as a name. And it really is a kind of string anyway, and it also helps us manipulate and makes it easy for us to just delete a string as well. So we've got a paragraph here, and then I'm using a little bit of the kind of responsive design. So I've added a style. So as well as these HTML tags, we can also have CSS tags. So this is basically adding a style, and this can be just a your own custom style, or you can use styles from things like Bootstrap and Bulma and other kind of CSS frameworks. So I could actually include like a CSS framework in the dashboard as a link to that, like the content delivery network version of it. But here we're just using a simple style, and we're using the flex display to basically create rows. So if we narrow down the size of these things, then it will be a row of data. Did I do another? Ooh. Huh. I've done some more of the dashboard, but okay. I think I lost some of my code. Oops. Sugar. Okay. Oh yeah. So this is kind of like just put the dressing on it, so the title and the paragraph around it, and then inside our kind of responsive design section of it, then we're just using this Vega Light tag to basically put in our views. So this is the same as doing kind of Oz view, but kind of waiting until we do the whole dashboard. So these views, these kind of data sets we're doing, this kind of data is basically something called the grammar of graphics. And if I go to go to the blog. Yeah, so the views are kind of based on this kind of grammar of graphics. So there's a really nice, really interesting video on the Oz website. And it's also linked here as well, which goes into a lot more detail than I've got time for today. But it shows you, so it's worth kind of watching that video to see like the art of the possible. And you've got things like, yeah, so we're showing here kind of like mark is what we've included in here, encoding and data. So these are all the kind of, these are three things that we've included in our data structure that we're going to create. And Oz is really a kind of wrapper around or generator for like Vega Light and Vega data structure. So Vega is a low level specification, where Vega Light is a bit more abstract, and then Oz is on top of that to just basically generate kind of Vega Light, mostly Vega Light data for views, and then that's why we're using this Vega Light tag in here to say this is a data structure that's in the Vega Light format. So there are lots of there's lots of different things you can do. I could spend all week playing around with different graphs, and I'll come up with I haven't actually got all the names of the graphs. I haven't found a reference to see what all the graphs are called, but that's something I'll work on this week as well. Okay, back to the code. So we're including the title and stuff, and then our two views that we've already created. So once you build those up, we can evaluate our dashboard, and then we just view our dashboard. So let's put the website back in again, and so that's what it was showing. We evaluate that, and we get our dashboard. that's a bit more. There we go. That's our dashboard there, and you can see that it's not quite responsive design, is it? Yeah. Oops. Oh, broken it. Oh, and if you want to reset something, then actually just refreshing the browser, just doing like Control R on the browser, does clear it, and then you can just re-evaluate a view, and it'll redraw that for you as well. So yeah, refreshing basically is just resetting the browser state back to a blank state. So if you do send a view that messes things up, then you can just refresh that. You don't need to restart the REPL or anything. You can just refresh your browser and send back the views that you actually want. Okay. Did I? Oh, okay. No, we've got this. Oh, yes. So I've got. Oh, yeah. So I've got another dashboard that adds some of the real data in. So just have a quick look at reading in the data, and we've covered this again in a little bit more detail in the previous two videos about reading in information from websites and from files. So in this case, we've required Java ClojureJava.io for reading in files. So I've downloaded the government data into resources as a CVS file. So I'm going to read the file. This is a general file reader with Java.io, and then I've got ClojureData.csv to change that into something more interesting. Change it into a Clojure data structure, so it's easier to work with. So, like, the simple approach would be to just read in the resource. So I'm using a resource rather than reader, and this will read in content from. If we look at the data structure, the project structure, so read in anything underneath resources. So resource here means the resources folder, basically. And so that's where we've got data, and then the daily indicators CSV. That's the path to the file, and the path to the file is just a string. So you can read in that file, which gives us basically a file reader buffer. So that's quite nice if it's a long file. It gives us a buffer, and then in this case I'm just slurping that all in, and then we're converting that into a simple Clojure data structure, just a vector in this case, just by using this read CSV function from the CSV Clojure.data.csv library, which is just a very simple library just to read and write in CSV format to and from Clojure data structures. So if we evaluate this, then we get the data that we pulled from and I've just printed this out. So we get the data from that daily indicators file, and we get the first data structure. That is, so this is a sequence of two data structures. So we've got, oops, it doesn't do that when it's comment. Oh, there we go. Let's just uncomment this for a second. Yeah, so we've got this list, and it's got a vector which has got all the headings of the data, and then it's got and then it's got the second vector, which is all the actual value. So that's quite nice and simple to work with. However, we really want to just be able to create a map for that, and so we want to be able to map date val with the dates and total cases with the total cases, and so on and so on. So let's just let's put that back again, minimize that. So we can create the map that we want very easily by using ZipMap. So ZipMap just takes two collections and combines them in a map using the first collection here. So the first collection is the first vector from our COVID daily indicators. So we get that, and we're going to use that as the keys. We could, if we wanted to, we could also wrap that in, I think it's key, is it keyword? I think it's keyword. Yeah, so name, yes. Yeah, so if we wanted to have keywords instead of strings, then we could use a keyword. So at the moment, without the keyword in, it's just using strings as the keys, which is fine. But if we wanted to have that as keywords, which is quite common, then we could just put the keyword in front of that as well. Does that work? Does that work? No. Or something like that. Yes. What did I do? Erase, there we go. But I don't need to do that now. I don't need to convert it really. There we go. So we can just generate this this map of data, and then we can use that to, I'll just put that in a def. So yeah, so it's just zip mapping the first, and the second is the values. So it's just joining the headers with the values, and there's only one set of data for the headings. So it's fairly simple just to create this map. If you've got something more complex, then you can use something called Semantic CSV Core. So this will create a map, and you can pass in CSV files, and you can do things like remove comments, mapify it, which will turn it into a map. And you can also cast things into different values. So you can cast strings into integers. That's sort of usually quite useful, especially if you want to use like values as in calculations, in mathematical calculations. So you can do that too. But for this particular case, I'm just displaying the data, so I don't need to do anything too complex. So we've got so I've got a new dashboard I created. So it's fairly similar to start with, just heading and paragraph. And then I've added, I've got two divs here, which are, one is for the headings, so like the daily indicators, and the other one is the two plots, the two graphs that we created as well. I did copy paste this, so I'm going to just tweak this bit. So we want what do we want? We got total UK cases, and let's do England cases and Scotland cases. Yeah, let's do those. So I'll do so here we're just basically going to pull out, because it's a string, we're using the get function to get from the map of data. We want the value that's pointed to by the key English cases, and this one for Scottish. I guess it's Scotland cases, isn't it? I think that's right. And again, these are just the keys from here. So we've got England cases and total UK cases, etc., etc. And I can also pull out the date value as well for that as well. So again, I don't need to hard code anything like that. In fact, I could change this. So we want and we want to we're going to create two strings, so we're going to have to wrap those together. So I want to do get from COVID the indicators map, and I want the value that's pointed to by date val. So that's going to return a string, and that's going to return a string. So I'm just wrapping these in str. So I'm getting a single value, slurping those in. So we got, so headline figures for that particular date, and then the figures themselves, and then the plots. So hopefully that all works. Nothing like live coding. We'll find out. Let's see. Let's bring back my web page and evaluate that. Oh, there we go. That's not quite right, is it? Oh, okay. Yes, it is right. I didn't change these. So England cases and then Scotland. So being able to do kind of this quick round tripping, again, it does make it much easier to much easier to kind of make sure that you've got the right information in the right places. You can see that I need to put some styling around that to kind of spread these out and make them into their own containers probably. So I'll investigate using kind of Bootstrap, or if there's any other kind of visualizations I can use that are built into Oz or Vegalite. That would be quite useful as well. But you can see it's very quickly, and even though I've explained this, it's still a very quick and simple process of, once you've got the data, you wrap that data inside a view that we've created. So here we've got the stacked bar, for example. So we get the data, we put it into our data section here. We say which visualization we want, and then how we want the data from to be represented inside that particular graph that we've got. And that's it. Obviously there's a lot more things you can do, but that is pretty nice and pretty straightforward, I think, way of creating visuals from data. And I think still the hardest thing probably is getting that good data source. I think that's always going to be the big challenge with any data science stuff, is getting a useful data source and transforming it into, and once you've got it, then transforming it into the right shape. That's not as hard, but it's actually just understanding the data source itself in the first place. And once you've got that worked out, then it's fairly straightforward. And we covered a lot of things in the video last time when we did the baby steps to pull in information and transform it into the right shape. So once that's done, the actual visualization side of things is pretty straightforward, I think. Okay, well, no questions. I'm going to leave it there. Thank you very much for joining me. I'm going to find the right button. Where is it? Oh, boom. There we go. Oh no, that's not what we want. Let's put that back there. Oh, there we go. Yeah, so if you want to reach out to me, then I'm going to add some more things to this blog a little bit. I'll put all links to the code and link it into how to install CLI tools. And there's a few little bits I'm going to add to the source code, but that's all there as well. So you should be able to look at that. I'm going to add that extra bit of dashboard with the headline indicators in there, and I'll play around with that a little bit more to add and make it look more interesting and more like our finished product that we're trying to aim for, which was the more like this approach. So it's all nice and responsive. And if you look at this on the mobile view, then you can see is properly kind of responsive design as well. Okay, so I'm going to leave it there. Thank you very much for joining me. If you want to reach out to me again, then feel free to. Ooh, it's stuck. Oh, it's doing strange things. My browser's doing strange things. Yeah, so feel free to reach out to me via Practicalli. There we go. And again, like the contact and feedback section shows you how. And if you got any comments about what you want me to cover next, then please let me know. I'm going to try and do some more data science stuff, especially around COVID-19, and see what other visualizations I can come up with. Okay. Thank you very much, and see you next time. Hope you have a lovely weekend and stay safe. Thank you. Bye-bye. Oops. Oh, I have to end stream now.